In this problem, we're given a triangle with sides 4 centimeters, 6 centimeters, and 7 centimeters. Inside the triangle is an inscribed circle of radius r. We need to work out what is the value of r. To start with, we're going to find the angle alpha on the right-hand side of our triangle there. And we're going to do this by using the cosine rule because we've got 3 sides and an unknown angle. So a squared equals b squared plus c squared minus 2bc cos a. So the a is going to be the 4, the one opposite our angle. So 4 squared equals 6 squared plus 7 squared minus 2 times 6 times 7 cos alpha. And if we simplify this, bring our terms together, we get that cos alpha is equal to 69 over 84. So alpha is equal to 34.772 to 3 decimal places. I'm now going to split this down the middle by putting a line from the centre of the circle to the angle alpha. By doing this, we can see that we've chopped into 2 congruent triangles. Now we know this because they're both right angles. We know they're right angles because we've got radius to a tangent, so they're right angles. They share a hypotenuse and they've both got a radius as a side. So by our laws of congruence, we've got our RHS triangles here, right angle, hypotenuse, side. So we know they're congruent, which means that this has chopped alpha down the middle. So we're going to create an angle beta here, which is half of alpha, so 17.386. So we now know that R is part of a right angle triangle, and we've got an angle 17.386 on this triangle. So if we can find either of the other 2 sides, we can work out R. I'm going to do this by finding the external sides. So if we look at the 2 sides here that I've labelled x, we know that they are the same by our circle theorems, because these are both tangents coming from the circle and meeting at a point. So those distances must be the same. And we can do the same on the other sides. So these 2 bits here must both be y, from where the radius touches the triangle out to the corner, and the top ones must be z. But we know the lengths of the sides, so we can create some simultaneous equations. We know that x plus y must equal 7 at the bottom. We know that y plus z equals 4 on the left-hand side, and x plus z equals 6 on the right-hand side. And we can start bringing these together to try and work out what x is. So if we do 1 minus equation 2, those y's are going to cancel, so we get x minus z is equal to 7 minus 4, which is 3. Now I'm going to call this equation 4. I'm now going to bring this together with equation 3 so that the z's cancel out, and we get that 2x is equal to 9, hence x is equal to 4.5. We can now use this to find our radius. So we're going to use tan because we've got an angle, we've got the opposite side which is r, and the adjacent which is x. So tan of 17.386 is equal to radius r over 4.5. So r is equal to 4.5 times tan 17.386. So it's equal to 1.41 centimetres to 2 decimal places. If you've enjoyed this video, don't forget to subscribe or check out more of my videos by clicking on the links here.